Okay, hello everyone. I hope you have scanned the QR code. Um, we will continue chapter 6 for a while, and maybe at the last 30 or 40 minutes, I will review chapter 5 and give you some exercise. Okay, we can start now. Okay, let me start with the uh, our Friday feedback. Uh, so we start from this statement. Okay. And the question is asking whether the statement is true or false. Okay. If we look at the statement, uh, it starts with the integration from -2 until 1. Okay. And the function is 1 over x with power of 4. Okay. Okay. If you just do the integrations, calculate, you will get it is -3 over 8. But if you look at the integral that is started with -2 to 1, when you look at the functions 1 over x with power of 4, when you look at the x equals 0, the function itself becomes undefined, or some part of the functions will be going to the infinite value. So, which means that the integral will not exist. It is false. Okay. The second question. Okay. Okay. So whenever you find a functions or an integral that is start from -a to a. This is f of x dx. You need to observe whether the function is an even or odd function. Okay. So first, we can check whether it's odd or even when we deal with the negative x inside the function. And when you plug in negative x, this will become a negative sine x, right? Because this is actually same positive, so no no change on the bottom. So it will be negative f of x. So it's the negative of its original function, which is we can conclude that the function is odd functions. And when we have odd functions, when we have this endpoint here, the results will be 0, as we mentioned in the symmetric nodes. Okay. I think last Friday I also mentioned that. So the answer is 0. The third one is a little bit, if you're not careful, you will have some mistake on the calculations, but let me start with this. So we start with the, we have integrations, okay, and we have 1 over 1 plus square root of x, and then with power of 4, okay. Now, if we let using the substitutions method like this, we are using u square root of x plus 1, then you will have du is 1 over 2 square root of x and dx, and this square root of x we can exchange with this one. Okay. So we can exchange the square root of x with u minus 1. So we have the dx is equal to, and then multiply with u minus 1 du. And check the endpoint. When x is 0, u is 1. When x is 1, u is 2. This is, uh, and then replace all with the u. Okay. Replace all with u, and then some calculation here, and careful doing this. Okay, careful doing this. Careful the minus and plus. Okay, and plug in 2 and 1, and you will get that this is 1 over 12 from here, and multiply by 2, it's 1 over 6. Okay. Okay. Okay, let's continue with, let me check what was, okay, we are in this part, the area between curve with respect to y. Okay, let's continue that part. Okay, we can continue with some example from the textbook. Find area of the region enclosed by the curves y equal 1 over x, y equal x, and y equal 1 over 4x. And probably we need to a little bit uh, roughly sketch the graph. Okay, roughly sketch the graph to see our intersections, or maybe our area, how it looks like. Oh, let's say this is not 1. Let's say this is 1 here. Okay, more or less, maybe like that, our area. This will be the area. Let me write A. Let's try and look at the area. If we are looking at the area and we try to look at rectangle dx, okay, let me draw. Let's try with the x first. Okay, for dx, we will have the area cut out becomes two area like this. So we have A1 and A2. So we need to know the precisely what is this, right? Should be one. I think this should be goes through here. Okay. If we want to confirm our point, we can make it into the uh, equations. So this is y equals square 1 over x equal x. So it will be 1 plus x 1 minus x. So we'll use the x positive. So this will be 1, 1. And the other part will be 1 over x equal 1 over x minus 4 over x. X is equal to 2 and half. Okay, at least we got all the intersections. Now first, when we have this, the using rectangle dx, okay, we will have the area will be, this is a1, a2, a1 plus a2 will be integral of x minus 1 over 4x dx. This is from 0 to 1 plus integration from 1 to 2 from 1 over x minus 1 over 4x dx. This will result 3 over 4, 3 over 8, right? 3 over 8 x squared from 0 to 1 plus this is ln uh, ln x minus 1 over 8 x squared from 1 to 2. This will be 3 over 8 plus ln 2 minus 4 over 8 minus ln 1 minus uh, 1 over 8. So this will be minus 3 over 8 here, minus 3 over 8. I cancel this 2, and we get the result is ln 2. Okay. And note that you need to be careful on calculations. Okay, this part calculation, the minus part, careful here. Okay? Sometimes you are maybe taking the opposite signs, and the results will be having a constant. Okay. Okay. If we look with the rectangle dy, if we take with the rectangle dy, maybe I will change the color into a little bit orange. So let's say we have this. That's our rectangle dy. If you carefully look the how the area will be, notice that we will have two parts here, precisely here. So this will be A1 and this will be A2. I hope you don't confuse on my picture here. Okay. So the pink color is the area, two area with our rectangle dy. Okay. So it's become two area, the top one here and the bottom one here. Okay. So why we need to have uh, two separate area? So that if you look at the whole area, it will be perfectly matched how the rectangle will move, and you can imagine that you can add all those rectangles. Okay. The problem is if you are taking the whole thing as it is without separations. If you take this rectangle from the top, okay, from the top here, and compare with the bottom here, this will be different in the height, right? The part on the top is y equal x with the y equal of 1 over x. The part on the bottom, y equal x and 1 over 4x. So different functions, right? So you need to separate those with two area, okay? Okay, so let me just erase this. Okay. So this part here, let me write a1 plus a2. This will be integrations, and let's start from 0 to this part, the half. So 0 to half. That will be, let me exchange all with, I forgot to exchange all. This is x equal 1 over y, x equal y, um, x equal 4y, because we are going to compute with respect to dy, right? So the first one will be 4y minus y, right? So this will be 4y minus y dy plus from half to 1, half to 1, 1 over x or 1 over y minus y, and then dy. So this will be 3 over 3y, 3y, and then we take the integrations, 3 over 2y squared from 0 to half plus, this will be ln y. Okay. And take some times to calculate. Let me check this. 3 over 8, right? Plus, this is ln 1 minus 1 over 8 minus ln half, okay, minus, oh, wait, this should be 1, sorry. 1's half, okay, so this will be half, 1 over 8. So negative half plus 1 over 8. This will be perfectly negative 3 over 8, and we can cancel this. Okay. This is 0. So we will have negative ln half, or this is ln 2. Same results, but how we can process it, it's up to you which method you are using. Okay? Sometimes using dy is much easier. Sometimes dx is much easier. Uh, Depends on how the graphs looks like. Okay? You can also tell from the picture, okay, what kind of function it is. Okay. And now, any questions? Any questions? Any questions? Any questions? Uh-huh. Okay. Okay. Let me check the. Mhm. Okay, let me give you a few example, and then we can move to next section. Okay. 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 Next section. Okay. First part. Find the area enclosed by the given curve. Okay, two questions. So probably you can draw first. Okay, you can draw the sketch. And then the area should be uh, the one that has all the lines. Okay, has all the lines. So the curves. So it should contain all the curves that is given in the questions. Okay, we can start from number 1. Let me copy this. B. Okay, if you have the answer, you can chat also on the chat box. You can write the answer if you have done the calculation. So this is 5/2. Cos x will be start from 1 here. Okay, now we have this area, this area here, area. It's the area that we want to observe. Okay. And we need to know the intersection here, right? So we need to know from cos x equals sine 2x. And you can look for sine x is half or x is pi over 6. So this is pi over 6, right? So we will have this rectangle here, dx, from pi over 6 to pi over 2, and yeah, x0, x over, okay, so we also from here, 0, so this is 2 area, okay, 2 area. So area will be equal, so first is, we can write in total with this, with this, with this statement, okay, and then we can separate this, becomes, this is cos x, and plus, and each one we can compute. Cos x becomes sine, sine to x become negative, so plus over 2, and we can compute this from 0 to pi over 6, and plus sine, let me write it like that. This is negative cos to x over 2, negative cos, negative sine x from pi over 6 to pi over 2. But let me exchange this to avoid mistake. Minus, okay, and this will be just plus. Okay, and area is sine pi over 6 is half pi over 6 plus pi over 3 plus 1 over 4, right? And then minus, this is 0 plus half minus. Okay, my suggestion is if you have like this computations, using brackets is helping, okay, to differentiate the signs. Cos pi over 2, pi over 2 to cos pi negative 1. So this will be a negative half plus 1. And I will bracket that. And then minus pi over 6 is half. And then this is 1 over 4. Pi over 6 plus half. This is 3 over 4. 2 over 4. Sorry. 2 over 4 plus, okay, 3 over 4. 3 over 4, 2 over 4. This is half. 3 over 4, 6 over 4. It's half. The first one answer is half. Uh, do you got the same result? Anyone got the same result with me, or uh, am I doing mistake here? Okay, please check it with your calculations whether it's correct or no. I think this is correct. Okay. If you look any mistakes, please let me know. Okay. Okay. The second part. Oh, still first part. Second curves. This is first curve. So the answer is half. Okay. The second one is y equal 3x minus x squared, y over x, and x equal 3. Okay. we can start with, let me just remind that this is 3 minus x. So x should be 0 and 3. So this is 0. Let me make it a little bit bigger. 1, 2, 3. Maybe 3 is here. It's x equal 3. And then this is equal y equal x. This should be 3 over 2, maybe here. Okay, let's say that is our graphs. Now the question first is which one is our area? So we need to have all these three curves, okay? 3x minus x squared, the red color, right? Y equal x, the blue one, the dark blue here, and x equal 3, the green one. The area that has three curves is just this, right? 1, 2, 3. The right part of the area, right? So this is our area. So we are only considering this area on the right. Okay. Okay, if we want uh, to break down this area, this will be this part. Okay. If you want to have dy, or if you want to have just, I think we can just have dx. Okay, just one area like that. No need to have separation. I think we just use dx to make the area, to calculate the area. First, we need to find what is this this intersections, right? This intersections is based on y equal x and the curves. So 3x minus x squared equal x. So we have x squared plus x minus 3x equals 0. So this will be x squared minus 2x equals 0. So x. So this will be 2. I think we are correct here. It's around 2. And yeah, so x0, x2. That will be the intersection. So we have area from 2 to 3 of x minus the curve is 3x minus x squared, and then the x. So this will be 2, 3, negative 2x plus x squared. And we can solve this, integrate this. Negative x squared, 2, 3 plus 1 over 3x cubed, 2, 3. This will be negative 9, negative 4. And then plus 27 minus 8. Minus 5 plus 9 minus 8 over 3. So it's 4 minus 8 over 3, or 12 minus 8 4 over 3. That's our answer. Okay, any question? Oh, this intersection here. Because in the picture, we are just focusing on finding this one, right? The red and the blue. Okay, great. Yeah, the red and the blue is the intersection that we want to have, because we need to know this part, because we want to put this intersection in our integral, right? Okay, here, this two here. Actually, if you draw really good, smooth, good proportions, you will know that, okay, this is maybe 2, but you need to confirm and recalculate to make sure that is it true or not. Okay, but if you draw good enough, you can predict what kind of point you have in the integrations. Yes, yes, yes. Yeah, sure. Okay, online students, do you have any questions? Okay, okay, let's see the third, the second part here. Okay, let me just copy this and take a new page. Okay, now we have uh, parabola x squared, uh, and then the other curve is its tangent line and x-axis. So maybe we need to draw, because not really difficult, right? It's just a simple parabola with a tangent line. So I think we can draw that. Let's say that's our y equal x squared. Okay, let's say we have maybe one is here. We have a tangent line that is maybe here. Okay, so the area will be this one here. Okay. The area is in between the curve yx squared, the tangent line at this point, okay, and the x-axis. So yeah, if you look at how we are having the area, if we take the rectangle dx, we will have some intersections we need to have here, right? Because we change the size here, right? So we have two area if we use the dx. If we use dy, however, if you look dy, let me write dy here. Let me draw the dy. All the area is the same height, right? And the same width dy. So I think we can use dy, okay, to simplify calculations. But if you choose dx, that's okay. But remember, when you use dx, you need to have separation here, the area 1, area 2. Okay, you need to have uh, separation. So when you use dx, let me. Okay, when you use dx, this will be, so you have area 1, area 2 if you use dx. But since I will use dy, then we will have first the equations we will rewrite in terms of y. So this becomes x becomes square root of y. Okay, and we need to find first the tangent line. So the tangent line, let me write here. Tangent line is we need to find the first derivative at x equal 1 is 2. So this will be the slope. And at 1, 1, this will be 2x minus 1. So y minus 2 plus 1 minus 2 plus 1 minus 1. And in terms of y, we can also write this 2x, or x is y plus 1 over 2. Okay, so the area will be, this is 1, this is 1 and 0. So from 0 to 1, half y plus 1 minus the square root of y. This is dy. This will be, let me write, uh, This will be 1 over 4. Or this is 1 over 4 plus 1 over 2 minus 2 over 3. One over 12, right? And now if you choose the dx, okay, if you choose the dx, if you choose, and the area will be, we need to find this one first. This is, we can find that this is how. This is x squared. And you can check this answer. Okay, since we already finished some example here, maybe if you have any questions, you can write down in the chat box for online students. If not, let me continue to the other sections in chapter 6. We will have more examples later. Okay, if we have finished all the chapter 6, I will have more exercise. The quiz will be a physical class, so you need to come to class. And I think for IITP students or the College of Engineering students, you have presentations, right? After our class Friday. Right? So I think it's better to come to the class, right? Oh, QR code? Okay, wait. QR code, QR code. Okay, so please come to the class this Friday. I will deliver your midterm results. Okay. And if we have the makeup exam, I think the schedule a little bit hard, but I hope, okay, if we can make it on December 25th or 26th, that is the only available time, okay, because the next week is already January, and January is, I think, the end of our semester. So we only have 2 or 3 sessions left. So I think we will finish until chapter 7. Okay. So chapter 6, I hope we can finish this week and maybe next Monday. And after that, we will focus on chapter 7. That is the techniques of integration, strategy for integration, also improper integral. And yeah, I hope we can finish that part. Okay, so if we have make up exam, the only available time is between 25th December or 26th December, between those two schedules. So Saturday or Sunday. Okay. Uh, If not, maybe if we can have early, maybe 19, maybe 19. Okay. But if 19 is it's too sudden, maybe 25th or 26th. Okay, if we have a makeup exam. Well, it depends on your results, Joey. If you uh, this is optional, you can skip the makeup exam if you want. Not really necessary, unless maybe your score is too low for the midterm, and I suggest to take the makeup exam. Okay. Maybe I will write here. So makeup exam, 19 or 25, 26 December. Unless you want to do it on January. But I think January is full of final exam, right? Too many schedule. I think better before January. Okay, I will tell you later the details. Okay, for the makeup exam. Okay, let me continue the uh, the session. Let me continue to um, the volume. Let me take some files for a while. Okay. Okay, now we start this second section on chapter 6. This is about the volume. Okay, so if we have a solid volume, okay, and if you look at the uh, xy axis like this, we start with the intersections of the solid volume here, okay, which is the ax, okay, this intersection here. We start from here. And if we cut with different side, from here we cut, from here we cut, we'll have a different area, right? We'll have different area, and uh, as x increase from A to B, the cross sections area also will vary. Okay, so ax will vary when x increases from A to B. Okay. Now imagine this is like a like a bread, like a bread, like a bun. Okay. So you buy a bun and then you cut, you cut, you cut, you cut, and eventually what you will see is So it's actually pretty similar with what we have studied. Um, we have a delta x, but now we have a 3 dimensions structure or solid. So we have a delta x here, and this will be similar to our rectangle. Okay, similar to our rectangle, but it has a solid structures like that. And if we divide and takes for some several n, we will have this a lot of slice, right? A lot of slice, and we can choose from like from A to B and how many slices we have. We can also approach this with the limit, okay, as n approach infinity. Okay, a similar thing. So we have the volume will be the volume. Okay, this is the area, and then the delta x. Now, if you look from here, okay, if you have a delta x here, so if you just imagine like a tube, the tube has a volume, the area multiplied by the height, right? It's just this. So area and height. Similarly, we have the area and then delta x, okay, for a uh, for a small slice of the volume. Okay. So what we need is we need to add, okay, all the volumes, all the slicing that we have done for some n, okay, some like a rectangle, right? How many rectangles we have? And of course, we deal with the limit again to justify the this approximation. So we have this to justify. So let S be a solid between x equal a and x equal b. If the cross sections area of the S, the solid, in the plane px through x and perpendicular to the x-axis is ax, precisely what we have in the picture here. Okay, it's ax here. Okay. Where a is a continuous function, then the volume of S is we can write as an integration of ax dx. Okay. Okay. That's the definition of volume in the integral Okay. Now, if you look at a sphere, okay, if you look at a sphere, let me draw a sphere. Okay. If you remember, the sphere volume is 4/3, right? This is the volume of sphere. Okay. Now, if we are trying to use our integrations approach for sphere, okay. So let's say we have we slice. Okay, we slice this. We slice. Okay, and let's say our information is just R. Okay, this is also R. Let's say this is Y. Okay, this is Y. And then this is X, right? I mean, Y is the height. Y is the height. Okay. The cross sections, and let me write here. The cross section is a circle. This is the equation. If we take this into just one side, okay, for example, we take as a function of x, okay, so this will be y equals square root of r squared minus x squared. Okay, now this is a function, our function, to determine the cross sections. Okay, now our area for the cross sections, this will be the uh, pi. This is the radius. Okay, so if you look closely here, we can take this as a circle with y as our radius, right? Okay, so this is a circle, okay, and this y here is our radius. Okay, y is our variable. Okay, we just take it as a y, okay, and this is x. Okay, so let's take radius y for the circle, for the cross section. So this will be pi y squared for the circle, right? For the a small circle inside the sphere. Now this becomes pi r squared minus x squared. Now if we compute, okay, if we compute, okay, if this is r, if this is r, this is 0, this is negative r, okay, in our coordinate. Okay? This is negative r here. Okay. Okay. Then the volume of the sphere, the volume of the sphere is integrations from negative r to r. We are adding this part here, like the previous solid. We take this plus 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 plus, right? So we will have this. Let me write here at the sides here. Okay. So we will have a tube like this, like a disc, like a disc, right? So this is y, and this will be dx. Okay. Okay. Do you see what I'm doing here? I'm doing. So this slice here will be this small slice, and we will add this with the other part. Okay, so we will add all those slices, and we can write this into the volume from negative r to r. Okay, and we write, let's just write ax dx first, and exchange all with pi r squared and minus x squared dx. Remember that the constant is r. Okay, so r is constant. Okay. Now, because of the symmetry, we can also write. Remember the symmetry part. Okay, we can write pi also constant. We can take outside, take from 0 to r. This is r squared minus x squared dx, and we can integrate r squared become xr squared minus 1 over 3 x cubed from 0 to r. This will be resulted in r cubed minus 1 over 3 r cubed minus 0. This will result on 2 over 3 r cubed. So this will be 4 over 3 pi r cubed, the volume of the sphere that we know. Okay. So we can imagine a sphere and then take sometimes to imagine the sphere having a slice, and then we take integrations and calculate those slices. Okay. Yeah. So most geometric, okay, that has some rotationals like this, or cone, or any shapes that has a rotations, we can mostly we can prove with integral. Okay. Like also maybe like this. This is also we can prove with integration, or any like a pyramids. Yeah, we can also prove with integral. Of course, square, rectangle. I think that's too basic. We can imagine that. Okay, what's important from this explanations for the sphere is this part. Okay, this one, the disk part, the disk. Okay, this important, because this will helps you through most of the volume calculations with the integral. Okay, integral volumes calculations. Okay. Okay. Now to introduce you how we are using this disk. Okay, let me write some notes. Okay. It's called the uh, volume of solid revolution. Like for example, let's say we have as y equals square root of x, like that. and we want to evaluate from 0 to 1. Okay, so this is maybe the question is find the volume of solid revolution by rotating about x-axis the region under the curve y equals square root of x from 0 to 1. So solid revolutions means that you can have a solid product or a volume of a solid by rotating the curve. Okay, by rotating the curve or area below the curve into x-axis or y-axis. Okay. So for example, in this example, we rotate about x-axis, which means this is our curve, this is our area under the curve. We rotate through x-axis. Okay. And if you rotate, we will have a solid, right? Okay. If we are having the rotations, let me write. Let's say this is, and again, we always draw our rectangle, the small rectangle, to imagine what it looks like. Okay, and what's important in this calculation is remember that I told you about the disk. Okay? If we take this into our rotations like that, okay, this will be having that kind of shape, right? If we all points we rotate and we have this kind of shapes. And the point that maybe our cross section here is our small disk, right? So this is the x, and this will be the radius. And in our case, the radius is our height here, our y, right? Okay. So the key is we need to identify which one is our radius. Okay? Which one is our radius? Because I think this is the example is very basic. So we know that the y will be, or the radius will be our y. Okay? Because maybe if we change the rotations, maybe the rotations is about the some line here, or maybe line here. It can be done, right? Maybe if we have the rotations is maybe at x equal 1. So you have this is your volume. So it will be different height, right? But let's say we are using this example. So we will have the volume is from 0 to 1. Let me write just area, function of area, and dx. So the volume will always have the pi, right? Because it's rotated. It's a circle. It has a circle equation. So it will have a area of circle. So r is y. So this will be integrations y squared dx. Okay. Y squared is our just x, right? So we have this is x dx pi. Sorry, pi. Okay, it's pi over 2. Okay. So the key is, remember, the disk, okay, the disk, okay, and also finding or identify the radius. Let me give you another example to see uh, other perspective. Another example, find the volume of the solid obtained by rotating the region bounded by y equal x cubed, y equal 8, x equal 0, about the y-axis. So first, you need to understand what's the actually the question. So we have volume, we have region. It's bounded by these three lines or curves, and it needs to be rotated through y-axis. Okay, so we need to draw the uh, x cubed, and then y equal 8, x equals 0, and then rotate it through y-axis. Okay, this is the picture. Okay, now from the picture, we are suggesting that we are going to use the dy. Okay, we are going to use the dy. Okay, because if you are using the dx, you will have difficulty, right? Finding which one is our radius, which one is our disk, and I think better we are start with dy. So we have a good shape of a disk, right? So we will have a volume from 0 to 8, and this is ay dy. And this will be, because the radius will be, this is the radius. So pi r squared, this will be pi. R squared will be y 2 over 3 dy. Eight is 2, 2 with 5 is 32. 32 multiplied by 3 is 96. So 96 over 5 pi. For the last 15 minutes, okay, I will go back to chapter 5 for some example for you, for some exercise, a small exercise. Hopefully we can have enough sufficient time for dealing with these questions. Okay. If there's no question here, we will go for some exercise. Okay. Let's see. If I have a limit as h goes to 0, I find the limit. Let's maybe we start with 2 or 3 questions. Let me check first questions. I give you these 3 questions. Maybe not all 3 will be solved today, but I think I can uh, show you the uh, later part on maybe the additional video, but let's just try this first. Let's just try this. Anyone got the result? Number one, first number? 3, right? Anyone got number one? Yeah. This okay. This okay. There are at least two methods to solve the first one. The first one is this, and the second one is L'Hopital. Yeah. Either way, it's short, not too long. Number one. Okay. Yeah. At least two methods. You can first use the L'Hopital. The second way you can use the limit definition of derivative. Limit definition of derivative. Yeah, x plus h. X plus h. Yes, that one. Okay. Okay. So for number one, let maybe um, this f. Okay. This is our. Uh, let's say this is 2x. Okay, and then this is 1 plus t cubed dt. Okay. If we take the derivative, this will be resulting. Right. Okay, if in which this is our problem. One over h, and then this will be from 2 plus h of our 1 plus t cubed dt. And we know from here that is our first derivative is 1 plus x cubed. Okay. Then this is actually saying that this is f prime 2, or this is 1 plus t 2 cubed, or this is squared 9, 3. Or if you want to check with the L'Hopital rule, you can always also do that. So right, because if you check when you plug in this 2, it's 0 over 0, right? So you derive the first one, it's become 1 plus 2 plus h cubed. Sorry, we still have limit here. Limit h to 0, this is 1. Okay. And this will be 1 plus 2 cubed, or this is 3. Okay. Okay. I think the second one you can do it, right? The second one. The third one I think it will be more difficult. We still have time. Okay. So there will be no feedback time for today. So we can finish this. Now we are going to use the substitution method. Okay. Of course, if you look at how the functions here, this with E, it seems that if you want to check with another method, we need to have another method here, like integration by parts. But since we haven't yet been introduced on this class, let's just keep using the substitutions method. Okay, at most substitutions method. So if we let u is equal x minus 2, let's say that is our substitutions. We have x, u plus 2, right? Okay. Now when x is 0, u is negative 2. When x is 2, and when x is 4, u is 4 minus 2 is 2. Okay. So we will have negative 2 to 2. X is u plus 2, and e, and then u 4. Okay. And then du. Uh, this is, forget, du is equal dx, so du. Okay. Now what's happened next is we are going to have u e for du plus, this is 2 e u for du. And remember that we have this is k, right? Let me write here. Or if this is e u for du negative 2 to this is k. So this is will be 2k. And how about this? Remember the odd and even. This will be 0, right? So the answer will be 2. This is odd function. Okay. Okay, I'll leave out the second questions for you to check. This is, but let me give you just a quick idea. Okay. So u will be x squared. So du is 2x dx. So dx is 1 over 2x du. So we will have half. This is a square root of 1 minus u squared du. This part is sine inverse, right? So this will be resulting half sine inverse u is x squared plus c. Okay, I think just that. Okay, finish. Okay, that's some example for you. Okay. Oh, okay. QR code. Sorry. Okay. Yes. So don't forget, we will have a quiz on Friday. So please come to the class. We will have a physical quiz. Physical quiz. Don't forget. Okay. I think that will be the end of our lecture. No feedback today, and hopefully you can join the quiz Friday.